So in this class, I will solve a problem of locating centroid of a composite section. VTU question paper problem, January 2020. The question is like this: determine the position of centroid of the shaded area shown in the figure with respect to point O. So point O is here. All dimensions are given in millimeters. Okay. So here, since he has asked with respect to point O, and the section is not symmetrical about any of the axes, where horizontal or vertical axis, the procedure is I will take the bottommost edge as the x-axis, leftmost edge as the y-axis. So OA produce this y-axis, OD produce this x-axis, and you can see that this composite section consists of simple sections. So one rectangle is there of dimension 200 by 100. One triangle is there of base 200 mm and height of course 300 because it's a quarter circle. It's a quarter circle. So that radius itself is the height of the triangle now. So 300 mm and quarter circle of radius 300 mm and in that there is a circular portion cut from the lamina. Cutout portion is there of radius 50 mm. Of course, it is placed at a distance of 50 mm from this rectangle edge and 60 mm from this edge. So this is how the figure is given. Now, since it consists of four composite sections, simple sections: rectangle, triangle, semicircle, quarter circle, and circle. So I can just name them like this: one is the rectangle, two is the triangle, three is the quarter circle, four is the circle. Now, you know the procedure. We have to locate the centroids of these simple sections. We can call them as G1, G2, G3, G4, and we have to measure the distances of those centroids from the y-axis and x-axis. From the y-axis, distances are x1, x2, x3, x4. From x-axis, distances will be y1, y2, y3, y4. Now, if you do that, so let me take one by one. So this is a rectangle. So this rectangle is of dimensions 200 by 100 mm. Its centroid will be exactly at the center. So I will be taking G1 like this. Next, I will take this triangle portion, right angle triangle with base 200 mm and height is the radius of the quarter circle, which is 300 mm. Here the centroid will be here, G2. Now you can see here the distance of the centroid from this edge is 100 mm because the width is 200, and the distance from this bottom base is half of 100, that is 50. Here also in this triangle you can see that this distance from the vertex to the centroid, it is 2/3 of the base, that is 2/3 of 200. 400 divided by 3 is 133.33 mm, and the distance of centroid from here, vertical distance is 1/3 of 300 because it is from the edge here, so it is 100. So please you should note down very carefully the distances. So from the vertex it is 2/3, from the edge it is 1/3. So in the case of a triangle. Now quarter circle is there. Quarter circle is having a radius of 300 mm, and you know that in the case of a quarter circle, the centroid lies at a distance of 4r by 3 pi, where this 300 is the r radius. So this distance will be 4r by 3 pi, and the vertical distance is also 4r by 3 pi. This is also 4r by 3 pi. So where r is 300 mm. So you can calculate this. So 4r by 3 pi will be, r is 300 if you substitute. So 4 into 300. So 4 into 300 is 1200 divided by 3 divided by pi. So the value is 127.3. 127.32. It is also 127.32. So that is the location of centroid of this quarter circle. Then coming to the circle, which is a cutout portion, centroid will be here, exactly at the geometric center. Now here the distance Of course, here from here to here, you can see that it is half of the radius. Radius of the circle is 50 mm. So half of that will be, this itself is radius. So radius itself is the distance 50 mm. Similarly, the horizontal distance is also 50 mm. So like this, first we have to write down the distances, x distances and y distances of the centroids of simple sections with respect to the x and y axis. Then we can locate the centroid. Now, as usual, I will solve this problem by writing the values in the tabular form. So serial number, figure, area I will take it as AI, it will be in millimeter square. Then x distances, xi, which is in millimeter. So x distances are measured from this y axis to the centroids G1, G2, G3, G4. Then y distances, yi in millimeters. Y distances are measured from the x axis to this G1, G2, G3, G4. Then I have to take the product ai, xi, so millimeter cube, and ai, yi, that is also in millimeter cube. So this is the tabular column we should have to locate the centroid. Now here, let us take one by one. There are 4 simple sections here. So one by one we will write the values now. Serial number 1. Figure is first one, I have taken it as a rectangle. First one is a rectangle, second one is a triangle, third one is a quarter circle, fourth one is a circle. So please note that this area is negative, my negative area, because it is a cutout portion. So figure 1 is rectangle. So area of the rectangle is 200 by 100. So which is 2000 millimeter square. Now the distance of the centroid G1 from the y axis. So y axis is here. So G1 is here, G2 is here, G3 will be somewhere here, G4 is this. So this is how I have written there separately. G1, G2, this is G3, this is G4. So we have to write down the distances of this G1, G2, G3, G4 from the y axis and x axis. First, let us write the distance, xi distance. Xi distance is for this G1 is this horizontal distance, which is nothing but 100. So from the y axis, it is a distance of 100 mm. Yi distance is this distance because this is x axis, which is 50. So I have shown that there. This is 50. Then second figure is triangle, right angle triangle, whose area is half into base into height, which is half into 200 into, half into 300, half into 200, half into 200 into height is 300. Okay, so this value is now 100 into 300, 10, I think it is 30,000. 3 followed by 4 zeros. So that is the area. So 200 into 100, this is 200 into 100. So 20,000 for the rectangle. Yeah. So for the triangle it is 30,000. Now the value of x for the triangle, it is x2, I can say. So here measure the distance from y axis to this G2. I have shown here. This itself is your y axis. Okay. So from the y axis distance is 133.33. 133.33. Since it is to the right side of y axis, all the values are positive here. So that's why when a figure is not symmetrical about any of the axes, you can choose bottommost axis as x axis, leftmost axis as y axis, so that all x values and y values will be positive. So then yi is the vertical distance, that is distance from x axis to G2. So here you should be careful. This distance you have to take 100 plus this distance. So that distance is 100 here. So from this edge here it is 100. So 100 plus 100. So it becomes 200. 200 mm is the y distance. Next, the third figure is quarter circle. Quarter circle whose area is given by pi r square by 4. Circle is pi r square, semicircle is pi r square by 2, quarter circle pi r square by 4, where r is 300 mm here. So pi into 300 square by 4. So if you simplify this, you will get 300 square into pi divided by 4. 70658.8. So 70685.8. So this is the area. Now x distance, that is the distance from y axis to G3. So which will be this 200 from here to here it is 200, from here to here for the quarter circle you can see here that is 4r by 3 pi. So that becomes now 200 plus 4r by 3 pi, that is 200 plus 127.32. I will write that 200 plus 127.32, which is 327.32. Then y distance, this d3 will be from x axis, which is to think about from here to here it is 100 plus 4r by 3 pi. So once again 4r by 3 pi is 127.32. So 100 plus 127.32, which is 227.32. Next, lastly you have circle. So the circle is not it is a whole portion, therefore area is negative. You have to take minus. Be very careful here. So for whole portions, cutout portions, area is taken as negative. So for a circle, area is pi r square. So minus pi into r, radius of the circle is 50. So pi into 50 square. So it becomes 2500 into pi. So which is 7853.98. 7853.98 millimeter square. Now the values of x and y. So x is the distance of this G4 from y axis, which is from here to here it is 200. 200 plus 50 plus another 50. So from here to here 50, here to here another 50. So 200 plus 50 plus 50, which comes out to be 300. Similarly, y distance from here, from x axis, you have to measure the distance to this G4, which is 100 here, 100 plus 60 plus another 50. So this distance is 50. So 100 plus 60 plus 50 means it is 210. Now once you get these areas, x values, y values, all those things, now you can calculate the product. Product is AIXI and AIYI. So calculate the products and then we have to add them to get the sigma values. So here I need the sigma value also. Sigma AI value I need. So if you want sigma AI value, so here you can see that the first three values are positive, last value is negative. So 20,000 plus 30,000 is 50,000. 50,000 plus 70,685.8 minus 7853.98. So this is the answer. You will get 112.8318. 8318.2. 112.831.82 millimeter square. So this is the value of sigma AI we require to find x bar and y bar. Next, I have to take the product of A and x and I have to write here 20,000 into 100. So it is nothing but 2 followed by 6 zeros. So you should be very careful here when you are writing the product. So here 30,000 multiplied by 133.33. So 30,000 into will be 39999. 39999. 4 nines 00. Then quarter circle product is 70,685.8 multiplied by 327.32. 327.32. So the value is here 23136. 23136. 23136 876. 876.06. Please check the values once again using the calculator. Next you have the, for the circle it is negative because area is negative, product is also negative. 7853.98 into 300. So it comes out to be 2356194. 2356194. Now if you add all these, you get sigma ai xi. So please note that here also the first value, the first three values are positive, last value is negative. So if you add them, so you will get 2 followed by 6 zeros, 1 2 3 4 5 6 plus 3999900 plus 231 368 76.06 minus 2356 194. So the value is 267.80.582.06. So you should be very careful. Operate the calculator twice and check the answer. So AI, YI I need now. This is AI, this is YI. So 20,000 into 50. So which comes out to be 10 lakhs. Half of the 20 lakhs. Then 30,000 multiplied by 200. So it is 9 followed by 6 zeros. 1 2 3 4 5 6. So 90 lakhs. Then you have for the quarter circle, A is 70,685.8 multiplied by 227.32. It comes out to be 16068. 16068. 296.06. Okay, so this is the value. Next, the last value is negative because the area is negative. 7853. Area is 7853.98 into y distance is 210. So it comes out to be 1649. 335.8. So this is the value. Now if you add this sigma ai yi you are going to get. So first three are positive, last one is negative. So 10 lakh plus 90 lakh. So 10 lakh plus 9 followed by 6 zeros. Then you have that is 1 crore plus 160,686.06. Then minus 164,9335.8. So the value is 24418. 960.26. So you should be very careful in these values because the values are very high. So operate the calculator twice. Now once you get these three summations, x bar is given by the formula sigma ai xi divided by sigma ai, which is nothing but 26 780582.06 divided by sigma AI is 112.831. Now if you divide that by that, so 26780582.06 divided by 112,831.82, so which is 237.35 millimeter. So that is the value of x bar. Similarly, y bar is given by the formula sigma ai yi divided by sigma ai, so which is nothing but 244,18,960.26 divided by area sigma ai is 112,831.82. So if you simplify this, you will get 244,960.26 divided by 112,831.82. So the answer is 216.42 millimeter. So these are the values of x bar and y bar for the composite section and for the shaded area. Now once you get the values of x bar and y bar, you can always locate that centroid in the given diagram. So I will just show you how to locate that. So here, so this figure I will write that. So the given figure is like this, something like this. So this is the given figure. Anyway, I am not drawing to scale. So this is the given figure like this. Of course, here there is a circle cut here. Okay, it's not to scale. Now, since I have taken this as y-axis and this as x-axis, so x bar and y bar, they are measured from these x-axis and y-axis with respect to the origin O. So this is the shaded portion. Circle is the cutout portion. So x bar is measured from y-axis and y bar is measured from x-axis. So that means x bar is 237.35. So since here this is 200 and this is 300, of course I told it is not to scale. Just to I will show how to locate that, and this is 100. Now x bar is 237.35 means it is 200 up to here. You have to measure from y-axis. Then from there it is 37.35. So it will come somewhere here. So this is your x bar. I can say x bar will be something here. Then y bar is 216.42. So up to here, from here to here is 100. So I will take y bar to be measured from here. So from here to here 100. Then this is he has given 60. So 160. And this radius he has given 50. So that means diameter becomes 100. So it becomes now 100 plus 60, 160 will come here. Then you have 216.42. 216.1. Of course, this he has given as 50. So that means your x bar will come somewhere here. Because this x bar value is 237.35 mm. 237.35 mm. Y bar should be measured from this point. Of course, this will be now 37.35. So up to here it is 100. 100 plus 60, 160. Then to get 216.42, 56.42 will be left. So 56.42 I have to move. So that means it will come somewhere here. Somewhere here it will come. So this is the G. That means this value is y bar value. which is 216.4. So this is how we have to locate the centroid of this composite section. So understand the procedure. So whatever may be the composition you give, combination of many simple sections, among that we should know how to divide the given composite section into simple sections, so that their areas and centroids can be located, and measure the distances of the centroids of those simple sections from the reference axis, or that is x-axis and y-axis. They will be your x1, x2, x3, y1, y2, y3, etc. Then you write a tabular column. So write the values of xi and yi and ai, then take their products and use these to formulate to get the coordinates of the centroid of the composite section. And please remember that when the given figure is not symmetrical about any of the axes, then you can choose bottommost edge as x-axis, leftmost edge as y-axis, so that your x bar and y bar the coordinates will be positive. And whenever a cutout portion or a whole portion is there in the lamina, that area you have to take it as negative. So when you are adding, you are finding sigma ai, that area you have to take it as negative. So this is how we have to do the problem of locating the centroid of a composite section.